Hello, everyone. Welcome to BSides Tampa 2023. I'm excited to introduce our next speakers, Nikita and Kenny Brown. They will be giving their presentation. Titled "How to Be a Whistleblower: Exfiltrating Sensitive Materials Safely." They're going to save about 15 minutes at the end for questions, but if you do have any that come up throughout the presentation, they said you're welcome to ask them. So without further ado, you guys get started.
Appreciate it. Thanks, guys. And again, to reiterate, if you guys have any questions throughout the presentation, please feel free just to interrupt as needed. Focus with everything. So again, the topic is going to be how to be a whistleblower, exfiltrating sensitive materials safely. Over the intro here. Kind of a disclaimer too. Think of this as the red team exfiltration type of exercise. We're not telling you how to do it, but we're just looking at it from the eyes and the optics of being that purpose. So kind of what to look out for. Learning how to do this with documents as well as audio-visual material. That's good. So we'll first come over to documents.
Let's get ready to do some documents, right?
Very exciting. So first thing that's important to remember is that every document does leave a trace, or every contact leaves a trace, no matter what you do. I mean, this is a digital world. You can't hide from much of anything anymore. So just assume that anything that you touch and any interaction that you have with it is logged somewhere. I'm not a person that looks through logs. I just left the system track a minute ago, and they say that people do that, and I'm not that guy. But somebody is, so don't worry, it's out there. So I mean, this could be anything from access logs, whenever somebody touches a file, whenever you come to a door, anything. It's not just, just documents. It's a lot of different things. Print logs, whenever you print anything, even if it doesn't print, it sits in the spooler forever, it'll still have a log of that. So that's a good one. And then any other sort of miscellaneous thing, if you edit a document, if you have version tracking or anything on Microsoft Word, it'll have your name and everything associated with it. So just assume that anytime you touch something, let alone look at it, there's going to be some sort of trace following it out there. And then again, saving and moving stuff. So if you save a document, it'll have your name on it. If you move it off, if you want to copy it off of your computer, put it somewhere onto an external hard drive, that's there. Every time you plug a USB device in, that's logged. So I mean, somebody can always look back in and find out whose device it was, what you copied off. So if you're dumping a lot of data off your name, will actually pop up. So just assume that everything does leave a trace. And on top of that, things do even leave physical traces in the digital world. So, there's all sorts of things as stray marking. So if you look at highlighting on paper, or anybody that has something highlighted, that's something that you can look out for. Staple marks, if there were staples in there, that's something that could be easily identified down the road if you had to look back for it. And then even like stray printing imperfections. If you use the crappy knockoff toner for your printer and it leaves all the junk on there, that's something that's usually like a footprint that you can come back and find later on. Next thing is microdots. Anybody ever heard of microdots? Okay, good. Didn't expect that, but that's something that is out there. There's an article here, we'll send this out afterwards, but talking about microdots, and I'll run through just a quick little exercise about microdots and then just to kind of demo it for people. So you guys see? Okay, my screen. So, you want to talk about this?
Yeah, so 6 years ago or so, there's this online newspaper article that came out that leaked internal NSA documents. If you scroll down a little bit, you'll see that these folks reproduced the document. There's some redactions there to remove PII. And yet, there's a problem here. You can't even see it yet. Let's try zooming in a little bit. Let's go to,
Let's do
400%. Can you see that? Not quite yet. Let's, in this tradition of all CSI shows, let's enhance.
We'll take a screen capture of it, and then we'll pop it over into Photoshop. Okay.
This is, and those shows when they show digital forensics, this is what it actually looks like, taking a screenshot, popping it into Photoshop.
You can go into the
soundtrack.
You can go into the image, you can invert colors to maybe, oops, not that. Never use my touch pads there. Invert the colors. Still can't see much of anything. You can go do some adjustments and mess with the brightness and contrast. Turn the brightness way up. And contrast way down.
Now, did you start noticing anything on the screen?
There's some So a bunch of little blue dots out there.
These are a real world example of what microdots look like whenever you use generally any consumer grade color printer, or now even black and white printers. They will have tiny little dot imperfections on the printed page. And it's kind of amazing, kind of over and over and over. So even if you were to spot one, take it away, it actually fills the entire footer, or sorry, the header of the page. But what do these dots actually mean? So the EFF, the Electronic Frontier Foundation, actually has a handy website. You can scroll down to decode these kinds of things. And really all you do is you pop it into this interactive matrix on the site. You click submit, and it spits out what you can see above in the sample image. We're not going to take the half hour it will take to type in all the little dots.
I did that once, I'm not doing it again today.
But if you were to do it, you would receive a serial number that also includes the date and the time something was printed, right? And the reason this is important, of course, is because if you, somewhere when we talked about access logs, right, and printer logs, so now you have the date and time a document was printed out, and you have the printer logs of who printed it at that particular time, and there you go, you have your source de-anonymized, right? And that's actually, unfortunately, what happened in this story 6 years ago, is the person who provided the documents ostensibly or arguably was de-anonymized. They may not have been used microdots here because they had a trove of other evidence, but the point is this is a real world example of how this kind of stuff actually happens.
And to tie it back into the, leaving a trace, so just because you print something out, we're able to find out the timestamp of when that was printed, and they can go back and look at the printer logs to see who printed something at some given time to then determine the person that printed the document, and possibly be the person who was the document. So watch out for things. Maintaining plausibility is a good segue into that. So the overarching goal is to avoid anomalous behavior. So don't do something ordinary. Kind of sounds hard if you're trying to do a whistleblower, but if you're going to be one, just kind of keep it within your regular day-to-day activities. So, don't try to log into things at 2 a.m. when you're at home. You want to be off everybody's radar. Don't try to go dig up old documents or something that's out there. When you're downloading large amounts of data, like I said, trying to copy things onto a USB hard drive, you're going to copy 30,000 documents at 3 a.m. That's probably going to raise somebody. Accessing documents that aren't part of your regular workflow. So let's say you're just a normal IT guy and you're over there trying to open up, finance documents or something like that. Kind of avoid that. You're trying to be not promoting yourself.
Oh, this is a red team.
So also, holding an insider threat. So don't be adversarial. So if somebody does try to come and talk to you about it, don't be aggressive towards anybody who's back to you. You just want to be your normal person, your normal self. Be as calm as you can.
Yeah, so the thing to keep in mind is when you're working your way through a regular system during the course of your work, right? Everything like you open up your docs, you open up whatever files you need, there are a slew of secret tripwires hidden everywhere around the system that you're navigating that you're not seeing as long as you're not tripping them, or even if you are tripping them. We'll talk about that in a little bit as well. And that's something to keep in mind is imagine that you're, let's say, looking through a paper filing cabinet. Right? Imagine the digital version of that. There are a set of lasers pointed at that cabinet wherever you open a door, close it, take a file out, put the file back in, photocopy a file. Everything that you do in a controlled system that has a sophisticated intrusion detection system, a loss prevention system, an insider threat modeling system is tracking every little piece that you do. Sophisticated insider threat systems today track sentiment analysis. If your company just had layoffs and you go on Twitter and post that these layoffs sure suck, you're now flagged in an insider threat system with a risk score. That's the way these systems operate, right? If you express a sentiment in a private message on Slack, guess what? Your Slack admin can read all your PMs, likely has an automated sentiment analysis system that now flags that you and this person you talk to on your work really don't like this new policy that was implemented, right? You're never going to find out about the shadow profile you have in your risk score unless something else happens that also escalates that. So for instance, if printer logs show that someone printed out a document and let's say 10 people printed it out on that date and the document didn't have microdots, but they did have printer access logs. 10 people printed out a document that ended up in the press. Of those 10 people, one person went on Slack and messaged 5 coworkers earlier on about the fact that, gosh, they really hate this new policy document, right? Guess who's now the #1 suspect for having leaked that document? Right? So that's just something to keep in mind is to avoid tripping all of these sophisticated tripwires that loss prevention or intrusion detection or an insider threat detection system would detect.
So don't do anything outside your normal behavior, kind of act your normal self, and avoid doing things that are malicious. Honey documents are also worth mentioning. This is something that admins or security people can go out through your network across your different files and name it something that sounds enticing. So kind of like a honey pot for browsing on the web. This would be a honey document. Name it something crazy like private employee salary negotiations, or something anything top secret or whatever. It's going to entice somebody to click on it, and then you can at least have a list of people to go and double click on the document. It might be totally empty, but at least you then have a list of the names of people that are interested in it. And then to Nikita's point, you can kind of start to weave that into the narrative of all these other different items and things, and get down to a close source of who's providing that.
Exactly. Like, let's say you're browsing around your corporate network, and you see this file called salary negotiations, and you're like, now you take a peek, right? You take a peek, whatever, you think nothing of it. You don't get alerted, you don't get a note from security that, hey, why are you looking at this document? Really nothing happens, but again, your risk score in that insider threat modeling tool, whatever it is being used in the backend, just goes up, right? And eventually, the high-risk individuals, when a leak happens, will be the ones who will be looked into and scrutinized further. And the scrutiny, again, keep in mind that we're talking about corporate networks here, but the scrutiny oftentimes extends into your personal life as well. Sentiment analysis, like I mentioned earlier, is done on your private social media feeds. Companies can subpoena other companies for your records, right? They can subpoena Google for your access logs to your private Gmail. They can subpoena whatever phone carrier you have for phone carrier logs. And now the private companies sometimes can deny those subpoenas, but sometimes they can grant them, right? The point is to never make yourself a target for them in the first place. Alrighty, and now we'll talk a little bit about watermarks. So what Kenny just showed you guys, the microdots, that's an example of a watermark, right? Watermarks are these tiny, tiny little beacons. They can be text, spaces, numbers, letters, fonts, anything. The point of a watermark is to uniquely identify a copy of a digital item or a physical item, for that matter. And there's lots of broad tiers of watermarking. The first one is white space watermarking. So this is very straightforward. Musk famously made a Twitter post, I think a few months ago, claiming that this is how he catches Tesla leakers. And what he claims to do is he puts either 1 or 2 spaces after a period. Right? So, a sentence can start with either one space or 2 spaces. And given the unique permutation of that, and we'll talk a little bit about that in a second, you can form a binary signature, right? Like if one sentence has only 1 space, that's a 0. The next sentence has 2 spaces, that's a 1. You have, let's say, a 10-sentence email, and you slowly build a binary identifier, right? Like 0, 1, 1, whatever. And from that point on, every individual email can be identified. That's an example of white space watermarking. We'll talk about how this is for all these systems in a second. So the next kind of broad class of watermarks are stylistic watermarks. These are things that change the style of a given a given document. What this means is one version of a document can have one-sized font. Another version of a document can have a second-sized font. And you're thinking like, oh, like I'll be able to notice, like if I look at someone's screen and they have like a 0.8 size document, and I have a 16 size document. That's not how this works. It's more, it will be a 1/10 of an iteration, right? Or 1/100th, right? These will be minute imperfections that you're designed not to be able to spot, that whatever editing software you're using may not even spot. But let's say you're trying to be sneaky, you open the document in Word and you check the font size, right? And it still says 12. What you're not seeing is that it's actually 12.001, as opposed to another version of a document that's 12.007, right? And all of these unique imperfections, when taken together, form, once again, a unique signature. That's kind of the purpose of all watermarking, is to form this unique signature in whatever language you want to use, whether it's actual code, or whether it's the syntax, the semantics of a document, the spacing of a document, the style of a document. And on that note, the third big group of watermarks are syntactic watermarks, or what we call structural watermarks. These are watermarks that now begin to impact the actual text of the document itself. Syntactic watermarks literally insert extra extraneous syntax into a document. So you all know what an Oxford comma is, right? That third comma in a list after the word ends. Some editors love it, some editors hate it, some don't care about it. Watermarking systems love it, right? Because you could have a unique combination of commas in a document that would still be syntactically correct when run through a grammatic parser, but it would uniquely fingerprint that document. And then finally, we come to the most pernicious class of watermarks, and what we call NLW watermarks, or natural language watermarks, sometimes broadly known as semantic or just word trace watermarks. And the way that this watermarking system works is it changes the actual sentence structure of a document. And these changes are made to kind of be meaningless in the sense of they don't impact the meaning of the document, right? So they keep the meaning intact, but they change the actual word orders. So, if you're watermarking a poem, right, or even a novel, this probably will not fly, right? But on the other hand, if you're moderating its general corporate email, they're very easy to do. And, trivial example that I always like to use is something as basic as the word order in a common sentence, like yesterday I went to the park versus I went to the park yesterday, right? Repeat those kinds of differences throughout the whole document, and eventually you have an automated system for tracking. So now that we've talked about the actual one.
Just one thing, so don't forget about homoglyphic watermarks. So if you look in the middle, characters there, I don't think it carried over with it in the PowerPoint, but at least in Google it did. So people can type letters and documents and things using different forms of us. There was originally
So can anyone tell the difference between these three O's?
carried over. I can't even tell.
Anyone? What's the different sizes? No. Here, I mean, they may look different size. You're right in that's the way PowerPoint presents them, but ideally imagine they're the same size. There's something else off. Yep.
It looks like each O, the space in the middle, you think it's smaller or larger?
Again, all those kinds of physical permutations we're seeing is probably due to the way PowerPoint described it, and that could be an example of a spacing watermark, but not in this case. So the kind of watermarks that we're talking about here are the homoglyphic watermarks. So anyone else back there?
Well, yeah, like this different CF or ASCII.
Exactly.
That's the difference between.
So in fact, that first O is the standard Latin O that we see in the character sets that we use. That second O is from the Greek character set. And that third O is from the Cyrillic character set. Right? And that's what a homoglyphic attack is, right? It's an attack where the letters look like homograms, like identical to each other. And again, if you have a unique combination of these, you can form that signature. Yeah, and in fact, a very famous large tech company is known to use this method when sending company emails to catch potential leakers. Right, and now we'll get to talking about how to subvert each of these systems in a second. But first, we want to address a couple falsehoods that people have about watermarks. So the first kind of thing that people very, very often tell me is, like, okay, you're concerned about, like, if I get a copy of a document, it's individually marked, but what if I get a group email, right? What if I get an email that's sent to my whole team, my whole department, or even all staff, right? Surely that's fine to leak because it'll be identical, right? By definition, it's sent to everyone. Not quite. Right? We're dealing with a sophisticated watermark system. Remember that a group email is just an email alias, right? An email alias usually points to a list, right? You could have anyone you want in that list. What a sophisticated watermark system would do is it would remove everyone except that first recipient, watermark the email, send it, subtract first recipient, add second recipient to the all staff list, et cetera, iterating until every employee gets an all staff email that is individually tagged. So this is kind of really key also that we want to address is don't assume just because something was sent to everyone that's no longer individually tagged. It's still very, very doable to individually tag it because remember, an email list, you're not actually seeing everyone, right? You're just seeing that all staff and you don't know the contents, the membership of that all staff.
And another falsehood too, to kind of go back to what Nikita was talking about, is the different permutations of how you can do all the different watermarking things. So it doesn't need to be complex in order to find something. It could be really simple, like you was talking about, just the binary stuff, the spaces, 1 or 2 or 4 things. And it's interesting how quickly this can kind of escalate in terms of the different permutations there are. So in order to figure out how many there can be, it's basically x to the y, where x is the number of ways a watermark can be added in, and then y is the number of objects that are being watermarked. So for example, we had 1 or 2 spaces like he was talking about. We had 10 sentences in email. And anybody, I know we said it's a security thing, but it's math.
And now we tricked you. Now you're in a math class.
Can anybody say how many permutations there would be in this example?
99.
Keep going.
Not quite. So remember, 512. It's just,
Keep going.
otherwise, it would be 1024. Exactly,
Yes.
1024, right?
Absolutely,
And
yeah.
the reason is you have how many different permutations can you have? You can have 1 or 2 spaces, right? So your x is 2. And if you have 10 sentences, it's 10. So 2 to the power 10, exactly as you said.
And
So
that's just for this. So you can add on other things like, microdots or anything else that just keeps going up from there.
exactly. And so kind of the point of bringing this up is people are like, oh, if you only have 1 or 2 spaces after a sentence, if you can't watermark that many versions, and if you have 5,000 people in your company, and actually this scales very, very quickly because if you add 11 sentences instead of 10, you now double it, right? Now you have 2048 permutations and so on and so forth.
This all brings us to how you bypass some of the watermarks. Pretty obvious, but Nikita can talk a little more
Yeah,
about it.
so we've talked about these different types of watermarks. Some are more sophisticated than others. The good news is that some are very, very easy to bypass. They just require manual work that people sometimes are not very wanting to do. So for the first 2 tiers of watermarks, we have white space and stylistic watermarks. All one has to do to get rid of this is simply retype the text. Notably not copy and paste the text, right? Because that would preserve at least some of the differences like spaces after periods, and also depending on where you're pasting things in, would preserve the different character sets, right? So when we mean retype the text, we do mean retype the text. We don't mean copy and paste the text, but actually manually retype it. And that's the thing is that these things are easy to do, but they're time intensive, which is why people are not prone to do them.
It's also worth noting if anybody attended our class yesterday, our training session on detecting digital. It's worth noting if you do type something and retype it, make sure the font that you're using is something that was within the time frame that you're looking to use it for. So if you're trying to link an older document, make sure that the font that you have in it is something that is time sensitive to that, like when it's creating a release. So you get really down the rabbit hole and figure that out too.
Exactly. And so now we get to kind of the more convoluted watermarks, like the semantic and syntactic ones. So retyping the document will preserve these watermarks, right? They're what are known in watermarking circles as being robust, right? Robust means that you could kick it, cover it in mud, whatever, it will survive. And the same thing is true with stylistic and natural language watermarks is if you retype everything, you keep preserving the differences. So kind of the point of attack here is to do what's known as a comparison analysis, right? Those of you who are comfortable with the terminal, right, you just do basic diff. Ideally, you would do a diff3, which would compare 3 different versions of a document. And the reason for this is, let's say you have 2 versions of a document, you do a diff analysis, which is just comparing 2 different versions. They're identical, and so you think that's great, my document doesn't have any watermarks. What's wrong with that? The issue that could be is that that document was watermarked not to an individual, but to a particular team, right, or a particular subset of people. Oftentimes what insider threat detectors will do is they will have a pool of suspects. Let's say you start off with, you have a 5,000 person company, you have a pool of 100 people who are your suspects. Why are they your suspects? Because going back to everything we talked about earlier, they've tripped up multiple intrusion detection and threat anomaly detection methods, right? They accessed files out of work, they accessed files an erratic number of times, an erratic amount of times, they posted negative things about the company on Twitter, and now they're a high threat individual. What then happens is that that group gets its own particular document, right? And when that group compares that document within their own group, they'll get a match, right? Because the watermarks will be identical to that one group. But if they were to compare that with a third document from someone from another department, they would then find that difference. And that's why I said sometimes if you're using the diff command in terminal, use the diff3, because then you have 3 different versions that you're comparing from broad a sample size as you can.
Kind of in stark contrast to the whole group thing, Canary Traps is another thing that you should watch out for. So an example of the all hands email, you could get an email that says all hands delivered to you with an attachment and assume that everybody got it, but you might be just the only single recipient of it when it looks like it could go to a larger group. So you feel like you're safe to leak it out, but then you're not, because you're literally the only one that has a copy of the document. So kind of keep that in the back of your mind too. You might be just the only person that gets an all hands email.
Yeah. And the point is that, we've talked about different methods that a document can be watermarked, but that document itself can, on the meta level, also function as the watermark.
So audiovisual stuff.
Alrighty, so we talked a little bit about documents, and now we will touch upon what to do if you're leaking, let's say, conference recordings. So especially now, we've all had our share of Zoom meetings, right? Sometimes they were less great than others. Yeah, maybe there was an impulse to leave a Zoom recording. Right? Maybe you're recording it on your screen, maybe you're recording it on your phone, maybe you're using Zoom's built-in recording feature, whatever. There's a number of concerns about this recording. The first is, if you're just recording a 2-hour meeting and you step away for a second, and you're recording your whole screen, maybe there was a split second where your mail app sent a notification, right? And you don't catch that because you looked away, and then you upload the file somewhere, you share it because you want to leave the recording. And then a careful forensic analyst, what they will do is they will break apart the video frame by frame, right? Very easy to do in FFmpeg, just export every frame to a PNG file, and then run an analysis to instantly, a standard hour-long video will be hundreds of thousands of frames. You'll run a simple program to detect any major changes between frames, and that notification that you get that you would have missed will stand out like a red flag. Okay? So that's something to keep in mind when you're recording, is to be cognizant of any stray signals. And by that, we don't just mean visuals, for instance, that notification, but any sounds, right? If you get a ding, that you got an email at that instant. What someone could do is go back, check the company email server, and check who got an email at precisely this timestamp, right? And now suddenly you know who recorded that video, right? And that's the point, that you need to be cognizant of all of these little factors, right? You need to be cognizant of, is there any stray sound, is there any stray video? Something as innocuous as a mouse pointer can give you away, right? You can see our mouse pointer here. We did before I touched it, and we vanished, but you saw that it was a black mouse, right, with a white outline, because we're on a Windows system. Mac system, I always get those confused. On the flip side, if you were on a Windows system, you would see a white mouse with a black outline, right? Why does this matter? Let's say you're in a corporate environment where 95% of the users are Mac users, and you happen to be in that 5% who's a Windows user, and your mouse appears on the leaked recording. The people doing that investigation now know that you're a Windows user, and when they correlate with all the other threat factors that they may have identified earlier, guess what? There's only 2 Windows users in that early high-risk group, right? So that helps narrow it down. And then one other thing to worry about, especially with Zoom recordings and other video conferencing platforms, when we start implementing this, is Zoom actually has the function to enable audio watermarking in recordings. What this means is each attendee in a Zoom meeting gets a unique audio stream that's watermarked, right? And the good thing is that for now, at least, it's possible to detect this in Zoom, where you can see on the top left of your Zoom window, you'll see this little sound icon with a lock. And if you hover over it, it'll say something vague like audio signature enabled. You'll be like, what does that mean? Audio signature is Zoom's kind of obfuscated language for saying that the video is watermarked, or say that the audio is watermarked. Right, so audio signature means audio watermarking. And then in terms of images, we looked at this a little bit earlier, right, when we looked at the microdots on the printer, but something to keep in mind is that any imperfection in an image can potentially reveal the source. Like, let's say you take a screenshot of your laptop, or let's say you're worried about taking a screenshot because what we just talked about, everything you do on a corporate asset is monitored. So when you hit print screen, that action goes to an audit log somewhere. So you're very hesitant to do that. You don't do that. Instead, you take out your phone. Take a photo of the screen with your phone, post it up. You think it's good because all you did was take a photo with your phone. You didn't do anything on your work computer that you shouldn't have, right? And your phone happens to have a dead pixel, just one, right? And let's say that you're on that risk of high threat individual that we talked about earlier. What the investigators will do is cruise over to your Instagram, cruise over to your Facebook, look through the photos that you've uploaded, run an automated GIMP script to see if you have that same dead pixel in other public photos that you've pasted. If you do, then that's now a pretty good identifier that you were the same person who took that photo. And a dead pixel is just a very trivial, obvious example. There are many, many, many other minute imperfections that a camera sensor will have that you will not be able to detect. This whole field in forensics, if you want to dig into it, is called SCI, or source camera identification. And there, basically every single camera that you guys have right now has a unique identifier based on imperfections in the image sensor, based on minor microscopic scratches in the lens that will not show up on a photo, but when they're combined with the image sensor, will produce a particular noise footprint in that digital photo that will then be possible to link disparate photos taken in different contexts together. The field is rapidly expanding to the point where now the corpus you need to train to be able to identify a photo is only one other photo. Right? So if you have only one other photo that you suspect, like let's say I suspect that Kenny leaked something, I look at his Instagram, I pull one photo from his Instagram, I look at the leaked image. SCI algorithms are sophisticated today to be able to make that match off of one photo. Years ago, it used to be hundreds of photos. You need to train the data set based on different camera models and so on. It's advanced to this point where you no longer need to do that. So the point is, any little thing can leave a trace.
And also back to the thing, like if you take a picture of your screen or something, you have smudges on your screen, and your person is using your laptop screen, you can absolutely go back and find all the fingerprints. Or if you catch the bottom corner or something that says like MacBook Pro on a laptop, you have to get that. You can limit the type of laptop or whatever screen you're taking. So be cognizant of what you're taking a picture of and what you're taking it with, and then all the metadata that's included in your pictures on your phone that nobody ever seems to care about, location, time, all that stuff.
I'm familiar, again, of another case of a very popular, let's say foreign-owned social media company that's really in vogue right now that had an unflattering news story come out about them that had a screenshot of an employee's screen in the news story. What I hear tell happened at said social media company is their security staff after hours went around everyone's desk and tried to find the computer that had that same smudge in the corner. So again, when Kenny casually mentions smudges, most of the things we're mentioning are from actual real world examples that we can't name by name, but that have actually transpired. So keep that in mind, that's something as innocuous as a smudge. Departments take very seriously.
So that kind of brings us to another principle that you should be aware of is a one-time use thing. So if you're doing anything sensitive, you want to have some sort of one-time use document, like maybe I'll steal Nikita's phone and use that to take a picture, but don't use work devices. It's kind of obvious. I mean, don't just make sure they blow on their own network. But also don't use your personal devices. It has your metadata, it has other things. You can track them back to other pictures you've taken, like you kind of said. I mean, there's a myriad of things that can be tied back to your own devices. So point being is just take a single device, go buy a burner phone, go steal somebody's phone for a little while and send it or do whatever. Just use it once, get rid of it, and move on with life. So
That's kind of the main thing to take away here is that oftentimes you hear the common troubles, if you're going to leak something, don't use your work phone, right? Basic things like that. But really the problem is using your personal phone can be just as identifiable, especially keep in mind what I said earlier about when these investigations happen, and if they're of a sufficient level to warrant that depth of investigation, the company that you work for will attempt to subpoena your private documents, right? They will attempt to subpoena your private Google Drive, your private WhatsApp logs, right? Or call logs, anything that they can get their hands on, they will attempt to exfiltrate from you. Ricky, and this brings us to our conclusion for kind of really the overarching point is there are many, many, many things to watch out for, like when leaking. You have to be cognizant of all of them, and you have to use your critical reasoning skills to kind of think through, okay, I have this, how could it possibly be traced back to me? Right, that's something you have to kind of keep iterating over in your mind and mull it over for periods and periods of time and think about, okay, I did this, but what about this? And really the main takeaway also is don't trust others to do this for you. Right? You have this tendency, if we leak something, they'll take care of it. As we've seen earlier, journalists, for instance, they try their best. They're not the most tech-savvy folks, so don't trust the journalists who saw that story, which led to the arrest of the leaker. You have to do this work yourself before you package it up to send it.
by no means are we condoning any of this.
No, again,
You're ready to go out and start your own.
yeah, no, again, just to reiterate, this is a red team exercise purely under the auspices of a fictional scenario.
Speaking of that, I have a question on that, and this may be a somewhat naive question, but you referenced threat modeling tools. Do you have any sense of how many companies actually employ those types of tools? And I mean, obviously, we're talking about different sizes, different shapes, different companies, but how prevalent are they?
If your company is larger than, let's say, 500 people, chances are probably 99% that they do in some form or other. The reason being is that most standard security and IDS systems and IDF systems are now actually transitioning to also do a combination of threat modeling.
That's the point, right? So there's tools that may not necessarily be used as quote threat modeling that will do other other thing, but it could also kind of be.
Exactly, because remember, like, if you have a sophisticated audit logging system, it's a very short away into transitioning that into a sophisticated insider threat system, right? So even if you have an audit alert system, right, that can be patched right into the intrusion system.
You're talking about like Zoom or audio. Are they like doing like ultrasonic ones and zeros basically? Or okay.
Yeah, in Zoom's case, that's, I'm not going to say literally the case. That is very close to being the case. Is Zoom employs ultrasonic audio watermarks, but that being said, and Zoom's watermarks, are not super sophisticated. You can defeat ultrasonic watermarks by setting off a breakpoint for the highest rate that you want the audio to go, but there are more sophisticated audio watermark systems out there. Some, for instance, work not by adding data, but by subtracting data. And that might mean that there might be a tiny, tiny 0.01, like the 0.000ths of a silent dropout, right? And when you combine all those silent dropouts, you then get the watermark. And the reason I bring those systems up is that they're much more resilient and robust to tampering and modification. And so the takeaway from that is if you suspect that you're dealing with an audio watermark, the best step would actually to be the same thing that we talked about when dealing with textual watermarks is retype the text, right? There's not a real reason to leak the actual audio file. You could just leak a transcript of the conversation, right? And that would completely neutralize any kind of sophisticated watermarks. And that's kind of I find that symmetry here really, really awesome, right? These systems cost millions to develop, sometimes hundreds of thousands to maintain on an annual basis. And all you have to do to defeat a multi-million-dollar audio watermark system is type out the text.
With the typing up text, but like a text-to-speech check, speech-to-text be detectable? Because most people are going to be lazy. And so basically, you hit an audio and you just put your phone in.
So the problem with using speech-to-text, and really it's kind of a general point that applies to much of this, is make sure that it's not cloud-based, right? Because what could happen is, let's say you use that text-to-speech, at a later point, your company subpoenas Google for your private logs, which again, they do. And if, let's say, Google would acquiesce to that request, and they now have in your browse history in Chrome that you went to this text-to-speech site, the next step is to subpoena the text-to-speech site, right? And request their logs and their potential for that file, right? So the point is, you could use assistive tools, but make sure that they're all local-based, right? You're not using, and this applies not just for text-to-speech, this applies to anything. If you're using an image editor, if you're using a document editor, do not use cloud-based tools. Don't use Google Docs, don't use your Word 365 synced up to your whatever drive, right? Use local-based tools for all of this.
You're a lazy whistleblower.
That's really what it boils down to. It is such a glib point, but it is also so important.
So my question is, like, we just listened to you guys for like 35 minutes, and we wanted to pull off the perfect heist. What would you guys do?
Well,
framed already. It's just for learning purposes. Don't be lazy. I mean, cover your tracks, go back and don't be lazy.
It's a matter of following kind of the principles that we laid out. Like the principle of one-time use is super important, right? People use their own phones for everything and reuse them, and every time you reuse something, you're leaving the same kind of trace. This is the same kind of issue that, physical forensics has had since time immemorial, right? Like the person drives the same car that they drove to do something that warranted investigation, right? Leaving the same exact tire treads. They use the same gun, right? All of this is very, very basic physical forensic and material evidence stuff, except just applied to the digital realm. And really, that's what we're finding is that lots of this stuff is not new in terms of the actual technical processes are new, but the actual nitty-gritty investigation is the same thing that materials investigators have been doing for years, right?
Yeah. How do you properly go about getting a burner phone to use text? Like when you write your phone number, isn't that tied to your name, address, or something? Or is there ways to circumvent that?
So again, that kind of gets into the question of like actual in-depth threat modeling of who your adversary is, right? Let's assume that it's anyone below state level for now, like less than state level adversary. They will probably not be able to figure out that you went down to the corner store, got a phone. Okay. So basically, the risk of going down that rabbit hole is that eventually, you scare yourself into complete inaction. Like, I can't do anything I do is tracked. And the point is, there are limits. If we talk about the extent that corporate actors can do is they can request subpoenas if they know who your providers are, right? If they don't know, they can request it.
Yeah, makes sense.
And that being said, with state level adversaries, it's a bit of a harder problem, but it's still solvable. To your point, usually through secondhand devices and virtual numbers.
But also going with your burner phone idea, you could also get someone else to go get it and then kind of get it back. So also not tracing it back to you, but back to that person.
Yeah, I was just wondering, like, could you, is there like a backend database where you could identify the registrant's name, their name to the phone number? Obviously, the phone number is probably the thing that's identified.
One thing with the burner phone is that, like, with the SIM card, in like certain movies, those movies where it's like John Wick is like, all right, you got 30 seconds.
Yeah.
So stuff like that.
Microwave, whatever.
Yes.
Got kind of two questions. Is one, are you, just out of curiosity, are you more of a fan of like you grab all the files you can at once and then get out, or like, or you keep dropping little documents multiple times over using different phones and whatnot? Second question is, have you done any cases where anyone actively kind of like sabotage someone by taking those watermarks?
So I'll answer your second question too, because that is a funny story that I'm aware of. Someone working at an intelligence agency wasn't happy with their coworker because their coworker got a nicer desk that had a window. And they were a junior staff member, and they had a nicer. None of them had offices, but they were sitting next to a window. This person was very, very irked, let's say, at that. What they did is waited until they went out to lunch, got on their computer, took documents while logged in as them, and then linked them to a random news agency. So to your point, that kind of framing does actually happen. The issue with it, though, is that it is very trivial to stop or to prevent further on, because when I talked about that earlier, Kenny was talking about the insider threat profiling, right? A huge sector for insider threats is employee grudges, right? A sophisticated insider threat program, which a government agency will have an internal database of inter-agency grudges, right? So employees have grudges at each other, and that's what happened in this case. The person who leaked those documents from someone else's computer, even though he used someone else's computer, he was caught within a week. And the reason is because his grudge was very, very open and known about in the office, right? So in fact, that was based on interviews. Right, in this case, what happened is when that leak happened, people didn't even suspect the person whose name was attached to them. They instantly suspected the other person because his animosity was so well done. So that's something to keep in mind as well when doing these are broadly known as impersonation attacks, right? Is that to make sure there's nothing to actually link the perpetrator to the person doing those kinds of attacks. Any other questions, thoughts?
I just wanted to share that I listened to a great privacy podcast. Mint Mobile apparently is the highly suggested carrier.
Mint Mobile is owned by T-Mobile.
So the reason being is Mint Mobile offers trial SIM cards that you can get on Amazon or wherever that cost $1 and then work for a full week. Oh, just as long as we're talking about Mint Mobile.
Couple dollars, just figured I'd share.
Thank you.
They're also owned by T-Mobile.
Fun fact. Thanks, guys. Thank y'all for coming.